Hello, everybody, and welcome to today's Hubble Hangout. My name is Tony Darnell. I work at the Space Telescope Science Institute, and today we've got a really interesting hangout planned for you. We've got Dr. Martin Barstow, professor at the University of Leicester, and also the president of the Royal Astronomical Society with us today. He's going to be providing us with a great introduction into not only the scientific and cultural impact of the Hubble Space Telescope, but also we're going to talk a little bit about the ATLAST mission a little bit later on in the hangout. But before I get started, let me introduce my cohorts. One of them is a birthday boy today.
Oh gosh, Carol, it's your birthday.
No.
Scott Lewis, our internet rock star, turns 16 today. So
yeah, 16.
Yeah,
yep,
that's great.
Absolutely.
That's great. Welcome. So congratulations, Scott. Also back from her hiatus from the workshop last week is Dr. Carol Christian, the Hubble Space Telescope outreach astronomer. Hello, Carol.
Hello.
Okay, before we get started with today's hangout and the introduction, let me tell you how you can interact with us. We hope that you will leave us comments and questions and tweet at us and all kinds of things, and we'll read them out throughout the hangout. We got so many last week I didn't get to all of them, so I'm going to start earlier this time, and we're going to go throughout the hangout with your questions and comments. So you can do it by using the Q&A app. That's the easiest way to do it, which is right there if you're on YouTube and Google+. You can also leave comments on YouTube and G+, and also on Twitter, use the hashtag Hubble Hangout, and we'll see those as well. Last week we had some pretty good interactions with those, and I'm happy that you guys are doing Twitter more on that as well. So thank you, and start commenting and leave your questions. So as I said before, we have Dr. Martin Barstow with us. He is the professor at the University of Leicester. He's also the president of the Royal Astronomical Society. And Dr. Barstow, thank you for joining us.
That's my pleasure.
Okay. For 24 years now, the Hubble Space Telescope has been circling over our heads and providing us and astronomers with views of the universe that have helped us not only understand how the universe works, but and our place in it, but has given us, I think, a lot of insights that I would bet most people didn't even expect to have before Hubble was launched. And I've often said that I've often called the Hubble Space Telescope the most important scientific instrument ever built because it has had such an effect, not just on the science and our understanding of the universe, but also the effect it's had on our culture. And I think anybody that knows anything about the Hubble Space Telescope and has seen some of the images that come out of it have had some kind of emotional reaction to it. I mean, I've told people often the story I had when I first saw the initial Hubble Deep Field in the 90s, in the mid-90s, and it wasn't until I understood the context of how that image was taken that it really hit me hard emotionally, and it in no small part led me straight to the job I have now. So it's affected my life in a lot of very personal ways. And I thought maybe you could give us a brief introduction on what your thoughts are on the kinds of science, both the science impact and the effect it's had on the general public.
Yeah, well, Hubble is the most well-known telescope on the entire planet, isn't it? Although obviously it's not on the planet, it's out there in space orbiting the Earth. And that is really the key to why it's been so important. Getting up outside the atmosphere gives you a view that none of us can have from the surface of the Earth. It gives you access to images that are not obscured by the atmosphere. It gives you access to different wavelengths of light that the atmosphere normally blocks, like ultraviolet and infrared. So the impact has been colossal because of that particular vantage point. One of the interesting things I find is that actually what you also get is a very dark sky. We get outside on a moonless night, and the sky looks dark to us, but actually there's a lot of light out there that telescopes don't like. If you go outside the atmosphere, you get rid of all that, and you get rid of the background, and you can see much deeper than you can from the ground.
I think so when Hubble was first being planned and launched, do you think that astronomers really had a good understanding of just how big a difference it was going to make, or was it always kind of understood?
I don't think so. Whenever you build a telescope like that, and I've worked on a few space missions, including Hubble, over my career, you have some ideas about what you expect to do, otherwise nobody gives you the money to build them. So you have to say what the science is going to be, but everybody always hopes underneath that there'll be things that are a great surprise. One of the things that made Hubble such a great surprise is the ability to keep changing the instruments, to repair instruments, to put on better instruments. And all the time Hubble has become more and more sensitive and more capable as those things have changed. So unlike most telescopes that tend to stay the same over a few years, and you start to run out of ideas of how to use them after a while, Hubble has kept on going, and the ideas have kept flowing through, because every time we have a new instrument, we have a new set of ideas, new exciting things to observe. Who would have imagined, when Hubble was launched in 1990, that it would be observing planets outside our own solar system? We didn't even know they existed back then.
That's right. So you can't even plan for that. And I've often said that some of the most important images that Hubble has ever taken, scientifically and culturally, have not necessarily been their most beautiful. I mean, if you look at something like my favorite image, which is the Hubble Deep Field, the image itself isn't all that pretty, but it's when you look at every single little grainy dot that you see on there and realize that it's an entire galaxy with hundreds of millions or billions of stars, then it really hits you on a completely different level than what a pretty image of a nebula might.
Yeah, I absolutely agree with that. Although, I have to be honest, the Hubble Deep Field isn't my favourite. It's one of them. But the images that I enjoyed most of all, because I work on stars, are those where you see new stars being born. These clouds of dust and gas that almost have this 3D appearance. The Eagle Nebula is one of the iconic ones.
That's right. When
it was first published, it just smacked me in the face and said, look at this. You're almost there. Even though it's hundreds of light years away, you feel like you're just sitting outside it, looking in, watching the stars being born now.
And that image that you're talking about, that's the Pillars of Creation one also, right? So that one is, you're right, it's become an icon. I mean, we see these images everywhere. I mean, I think I've seen Hubble images in diners, in movies. It's been on TV shows, things. You see them absolutely everywhere, and so they are easily, because of both their beauty, but also, Scott has it up now. He has that the iconic picture up now. Oh no, I'm being asked to update a plug-in all of a sudden, so I'm got distracted by that.
Unplug. Unplug it.
So timing.
I know. It's like, oh yay.
Adobe wants to update, you don't say.
Yeah, that's right. Especially not now. So so you just mentioned one of your favorite images. Carol, do you have a favorite at all?
I do have a favorite.
What's your favorite Hubble image?
Well, actually, I don't. That's not true. I don't have one favorite. The one that I had probably the most influence over, maybe by definition, that's the favorite, is the Sombrero. The Sombrero Galaxy. It's aptly named because astronomers sometimes, when we look at new images, we just name them whatever comes out of our mouths.
Sorry, that's how dark energy and dark matter happen.
Mine said, don't ever. Actually, Andy Connolly in a TED Talk said, don't ever ask an astronomer to name anything, including your children, because we just, it's like. It's kind of visceral. We just say stuff. Anyway, the Sombrero Galaxy looks like a sombrero. And it had been known for a long time. It's a favorite image, but then when Hubble looked at it, and it took many, many observations, we had to make a mosaic of it because it didn't fit in one observation. You start to see sort of amazing detail that you wouldn't have ordinarily seen, and it's got this big dust lane in it. And then on top of that, another thing which I liked about it was the cooperation with the Spitzer Space Telescope, and they took an image as well, and then you could see into the dusty part of the disk as well. So the two images together are really sort of amazing. And so that's one of my favorites. But I'm really a star cluster person, so there are a lot of the star clusters which I like as well.
Good, and Scott has a picture of the sombrero up now, and that is an amazing photo. That really is. It's one of the best ones. But again, I'm going to go back to these really not so. Some of the ones that really seem to move me are the ones that, like I said, aren't that attractive. They aren't that physically pretty, but what they represent is amazing to me. Like the first time we saw in NICMOS data from one of the astronomers here at the Institute was able to find in this little tiny, grainy, noisy, pixelated blob, we saw an exoplanet. And Remy Sumer had showed me that from some of the work that he had done. Just blew me away. It was just amazing what these images, what Hubble is able to do. So, Martin, let me ask you, what do you think are some of the most important contributions that Hubble has made to astronomy in its lifetime? And I know that's a big question.
How do you calculate those?
Yeah.
I think one of the biggest that I remember was the distance scale. Hubble was actually launched as part of its program to measure the distance scale out to Cepheid variables in nearby galaxies, and to use that as a yardstick to determine the age of the universe. So observations of galaxies like M100, I don't know if you could find that one of the first sets of observations measuring the behavior of Cepheid variable stars. And Cepheid variables, as people may know, are variable stars that have a period of variation, a timescale, that depends on how luminous they are. So you can really calibrate the distance by measuring that period. It tells you how luminous the star is, and then you get the distance to the galaxy. So you can compare that with the redshift measurements that people make about the expansion of the universe. And eventually you get to the age of the universe, which is now known very precisely. You can call it precision cosmology now, because within a few billion years of the start of the universe.
I know, that's an amazing thing to be able to say, because I remember when I was in college, my cosmology teacher was like, if we can know anything to within 20%, we figure we're doing pretty good,
Yeah, and now it's much better than that. So that's probably the big success from the early stage that sticks in my mind. I think coming down to the recent past, it has to be these observations of extrasolar planets, particularly those that are close in around their parent stars, where the atmospheres are evaporating, and when they pass in front of that star, you can study the atmosphere of the planet. And I think that's just an amazing piece of science. It's hard work, because you're looking at something that's very, very faint and almost overwhelmed by the parent star in terms of its brightness. But the fact that Hubble can do that is an amazing thing to me.
As we mentioned at the top of this, Hubble's been around for 24 years, and as you've already alluded to, one of the strengths of Hubble was its design, in the sense that it could be repaired. We can go up to it and replace instruments. As technology got better, we can make better and better cameras. And so we've managed to push Hubble about as far as we can go, at least in some areas. For example, I know the Frontier Fields program is using gravitational lensing to make Hubble a little bit more powerful, to see things that are a little bit further back. Is Hubble done? Is there any? Are we starting to reach the limits of what it can contribute, or is there anything new that it can still tell us about? And I don't guess I mean necessarily about seeing far away things, but just the general science that it's doing.
I don't think Hubble is done. There are so many things to look at that you will have to keep Hubble alive for a long time before you run out of things to do. I think we've gone past the point where we can improve its capability, and of course over time, sadly, things will start to break. So the nature of satellites in space, that some of the hardware systems have a limited lifetime, and there will be a point, hopefully a long time in the future, but eventually a point when Hubble won't operate anymore. So we need to try to do as much as we can in that period and observe all the stars and the galaxies that we still need to observe. And there's lots of science out there. I've been on the time selection committee a few times, and there are always something like 10 times as many ideas as there are time to do.
Yeah, we had a hangout on that a couple of weeks back where we talked about what it was like to get time on the Hubble Space Telescope. So it's very competitive, yeah.
Yeah, it's hard. I haven't got time this year, and I'm very, very frustrated. But I know that there are lots of other good things that will go on anyway, because it is so competitive, as you say.
Any thoughts on where that contribution might lie? Like, in what areas do you think Hubble will really be contributing the most in the future?
I think there are a couple of areas. You mentioned one, which is the frontier fields and the gravitational lensing. That's a really, really powerful tool, but it requires a lot of time to observe even quite small areas of the sky.
All right.
And I think
a lot of orbits. They've been given like several hundred orbits.
Yeah, and that's a really good investment in time. Another area where I think Hubble is unique is its coverage of the ultraviolet part of the spectrum, which is an area that I'm particularly interested in.
Oh, that's right. There's no other game in town for that wavelength.
There is nothing else. And when Hubble finally gives up, then we probably won't have any access to the UV until we build another Hubble-type telescope, which covers all the wavelength ranges.
I want to try something real quick. Well, I've never tried this before. We've got some viewers here. I want to ask you guys, but for those who are watching it live, can you tweet us what your favorite image of Hubble might be, or give us a quick story about how Hubble has influenced you and what impact it's had in you in your life. And I'd like to see what kind of responses we get from that. I'll read them as soon as they come in. I have a comment already on the Q&A app from Judy Schmidt, who is always watching with us. Thanks, Judy. She comments that one of the best things about Hubble and the reasons that Hubble images are everywhere is because of the openness of the science and release of data and images to the public domain. That's right. All Hubble data is free. Carol, do you have some comment on that?
Yeah, several comments. One is that I wanted to point out something that's really, I think, cultural change. I hope Martin agrees with me about science, which is that we were adamant about having an archive. And so when the data comes in, the observer, and we've discussed this on Hangouts before, the observer who specified the observation gets a chance to do some science on it, but then those data are available to the rest of the community and, in fact, the public. So the community then comes forward and they decide, oh, this object was observed, but wow, I'd like to know something else, and does an investigation on it. And in fact, the publications that are based on our archive are quite impressive. And that has been sort of a scientific culture change, which is archives are really important. A lot of observatories are like, oh gosh, it costs too much money. But it turns out the science return is tremendous, especially with the Hubble archive. And the second part is that we do share the images and we integrate them into educational products. And so not only do we share the images so you can have one, frame it, put it on the wall, but we also explain the science and integrate it into education so that people can understand what the scientists are doing and appreciate a little bit more about the universe in the process.
Yeah,
I agree completely about the importance of that. I think space astronomy, not just Hubble, has been particularly good at making data available. And for a scientist, that's really important. I think I've done more science with data that I didn't get because it was there in the archive than the data that I obtained myself.
Yeah.
Because when lots of people observe different groups of stars, you eventually assemble such a large amount of useful information that you can go back to it and you can extract things from it that you wouldn't have expected when you first made the observations.
I think,
real quick, I want to let people know, since you did do a call to action for people to find their images, I have screen sharing right now on, you can go to the Hubble site gallery, so where we have Hubble's top shots. You can actually go through a collection of 100 images that we kind of put out there, what, it was earlier this year, I believe it was?
Yeah,
we released this? And so this is a collection of many of the images that people like, but you can go through the entire collection if you want to share those out, and then use the hashtag Hubble Hangouts on Twitter to share them out so we can try to find those and see what you guys are loving too. Because there's just, as you can see as it's scrolling along, there's absolutely beautiful images that have been done with Hubble, and also some composite images with Chandra and Spitzer and things like that. So there's a lot for you to go through.
Yeah, thank you, Scott. As always, your idea was way better than mine. I guess all I meant was just shout out a name of a picture like Eagle Nebula or the Sombrero Galaxy or whatever. But that's even better. So if you want to go, there, grab an image, even better.
I was just going to make a little point, springboarding off of Martin's comment about the ultraviolet. I know you were poo-pooing the Hubble Deep Field, but you recall that earlier this year we had the ultraviolet ultra deep field, and that, even though it's a deep picture of lots of little galaxies, it's a stunning picture. It's very colorful. It's amazing. So that brings out the ultraviolet and also is used to understand how galaxies change and evolve and star formation rates and things like that. So the ultraviolet was very important for that observation.
Yeah, thank you, and thank you, Judy. Judy's also a big user of the Hubble data. So that was a great comment. So thank you, Judy. Let's see, Sev Dust Bunny. Sorry. I'm laughing at some of these handles here. Hubble launched when I was just a teenager, captured my imagination and sparked my interest in astronomy, offering never-seen-before imagery of the universe, and then got me into a local observatory, which allowed me to watch Shoemaker-Levy 9 comets hit. Wow. Thank you. That's a great comment, Seth. Thanks for sharing that with us. And you know what? He brings up an interesting point, about the Hubble generation. There are people around now who don't know a world without the Hubble Space Telescope. If you're under 24, you don't. Like Scott, for example, just turning 16.
Like me. I'm like...
Yeah, he doesn't know a world without it.
What's a rotary phone? I don't get that.
Oh, God, where's my Walkman? Okay.
Oh, dear.
So thank you, Seth. That was a great comment. So let's get to a little bit about the cultural impact of Hubble. Why do you think it's gotten so much under our skin? Is it because of the here's your place in the universe thing, or is it just the pretty pictures? I mean, what is it about Hubble?
It's not just the pretty pictures, but the pretty pictures are an important starting point, because if you want to communicate science and talk about what our place is in the universe, those images are just the best way to do it. And I think it's that beauty. Very few bits of science make it onto the front pages of national newspapers, and Hubble has done that many, many times. And I think underlying that is all the effort that goes into processing that data. Those pictures don't come around by accident. They don't emerge fully formed from the instrumentation without people doing an awful lot of work, choosing the right color palette that expresses the beauty and that shows the depth of the images that you're looking at. And that's what's driven a lot of this. I think it's the excellent work done by the people who produced the pictures before they're made available.
Were there any, I mean, what was before Hubble? Were there any orbiting telescopes that were able to do the kinds of things Hubble ended up doing prior to this?
There have been telescopes that produce images, but Hubble was the first one that gives you all this wavelength coverage, including the visible part of the spectrum. Yeah. I actually started out life as an X-ray astronomer in the late 70s, early 80s, quite a while before Hubble was launched, and we were getting the first X-ray images. But the resolution of those images wasn't great, and the detail, therefore, so wasn't particularly good. So they were kind of blobby things without a lot of information. I thought they looked pretty, but they wouldn't really look pretty.
But you were an X-ray astronomer, so of course you would think they're pretty, right?
So there were ground-based telescopes were beginning to do that, but most ground-based telescopes were still using photographic film to produce nice pictures. There weren't many electronic detectors around, and that was the key thing about Hubble. It was in space. It was carrying a first generation of electronic detectors that could record those images from space and allow you to process them and combine different colors of information across the wide wavelength range that really created those fantastic images. So Hubble is a truly unique thing. There had never been a visible light telescope in orbit before.
Yeah, I remember that first detector.
It remains unique because there isn't anything. And sadly, at the moment, there isn't anything guaranteed to follow it. I think James Webb will be a great telescope when it's launched.
Agreed.
But it's not going to work in the same wavelengths.
Right, and we've had not only the launch, but the many different service missions to continually upgrade it. So we sent it up there with the original detectors, but then we've been able to broaden its scope and what it can do, and observe into the near infrared and things like that. And I think it's really profound.
That's such an important thing. I've worked on, as I said earlier, a number of space missions. So you have to have your technology ready to go several years before a space mission flies. So usually the technology of your cameras is about 10 years old at the point at which you launch your satellite. So everything that's come along in the meantime isn't mature enough to go into space. So the ability to take the new technologies and replace the old ones with them has been a particularly powerful part of the mission.
I remember that talking about the early detector. I remember that really jagged-looking, sort of image that he used to take with that early camera. So yeah, I remember that. That was quite a while back. So that was one of the first CCDs. I did not know that.
Yeah.
So that's interesting. Okay, cool. So
I'm going to just mention something about the culture and visualization. I remember that over the years, because Hubble started creating imagery and then visualization of astrophysics based on the Hubble data, that all of a sudden other sciences started doing that. So now it's quite commonplace to see like chemistry, medicine, imagery of things that we never thought were interesting to look at are now being processed to make really interesting views of different parts of the physical universe, including our bodies, that no one ever before ever thought, oh, visualizing scientific data, what's that about? And it really exploded during that era of the electronic detectors and Hubble putting stuff out. And I think it was sort of helped along the path that now we do see. It's part of our life that we just have science visualization, and we expect, when people are talking about some phenomenon, it's like, well, where's the image? Just expect it. So I think that's interesting change.
I actually think one of the challenges facing astronomy and science in general is being able to not just taking the data is important, of course, and getting the images are important, but I actually think the real breakthroughs coming through will be in technology that allow us to ask questions, science questions, of this data in a really efficient way, because we've got so much of it coming down now. I think that some of the biggest advances in that technology are going to help us answer a whole new slew of questions that we just don't even know to ask right now. The comments are starting to come in now on the Q&A. Let me get to a couple of them. Cecil Morgan writes, favorite picture of HST was last shuttle repair mission with Mike Massimino that I watched live. Best mission ever. So that's...
Oh, definitely. I helped plan that, so I definitely agree with that one.
Adam Synergy is commenting, HST has had a profound influence on my life. My interest in astronomy is thanks mainly to the internet and the beauty of the cosmos brought to us by Hubble and other great observatories. Oh, P.S. Thanks, Scott Lewis, for spending time on your birthday with us.
You're very welcome, guys. Because I love you.
Yes, thank you. One more from Red Hot Bagel. Not about Hubble, but JWST and future missions. What's on the horizon for space telescopes? I picked this one on purpose.
I wonder why.
Upcoming missions are you personally most excited about? Which is a good segue into the next topic I want to talk about, which is the Advanced Technology Large-Aperture Space Telescope. I'm still going to read your comments, guys, as we get forward on this, because I know they're still coming in, but I want to switch gears and talk a little bit about ATLAST. That may not be your personally most excited one, but it is one coming up. So why don't you...
I've been anticipating it, and we were talking about it at last.
I
had to.
I know. Space at last? But never mind.
No one has ever made these jokes.
Ever made these jokes. This is new material.
First time ever. Yay.
You saw it here. Anyway.
So Barton, can you give us a brief introduction into ATLAST and what it's all about?
Yes. So this goes back a little bit to what I was saying a minute or two ago. So Hubble has this fantastic wavelength coverage all the way from the ultraviolet through the visible into the infrared, which James Webb won't match. It will provide the infrared part of that. And the big question is, what do we do about the UV and the visible light? And at the moment, there is no planned mission to actually replace Hubble with that kind of facility. So I think James Webb is an important step, but we need a step beyond James Webb, which actually really creates a second-generation Hubble-like space telescope that covers all those wavelengths and gives us the same coverage that we're used to. But of course, to do better science and to do some of the fundamental things, it needs to be a much bigger telescope. So it's a real technological challenge, and it's not going to happen overnight.
I'm sorry, did you say how big the mirror is going to be?
Well, that's still being debated. It will be somewhere between about 8 and 16 meters aperture.
You're kidding, a 16-meter telescope?
Hubble is 2.5, so...
Right. So I got an image shared right now showing the difference there, and also the wavelengths that both Hubble and James Webb will be able to observe in. But yeah, just we're seeing here 2.4 meters for Hubble Space Telescope's primary. Then James Webb's being 6.5, and we already know how absolutely enormous James Webb is.
That's right.
So thinking about a 16-meter primary would be wonderful.
Yeah.
It's not an easy thing to do. Building something that big, but
is there a graphic in there, Scott, of the space?
On the bright side, the technique of folding up a mirror, launching it into space, and then unfolding it will have been tested by James Webb Space Telescope.
Right.
So once we've done that, there's nothing to stop us doing it for a larger telescope, and that's really the concept, or one of the concepts that we're looking at for the ATLAST mission.
So one of the things that will probably need to be folded or unfolded in some way. Okay.
So certainly to get 16 meters, you have to have it unfold. You might be able to, with a next generation of launch vehicle, launch an 8-meter monolithic mirror. That is a single solid mirror. But also it would need to be very lightweight.
Yeah, that seems to be
quite hard to do.
That's another technological problem that JWST's tried to solve, is get the components or get these materials lighter. So ATLAST will need to be light, probably folded. When are they thinking of getting this thing up there?
Well, if you start now, it's going to be at least 15 years.
Have they started now?
How long it takes everything to come to fruition. You think about when we started talking about James Webb Space Telescope. That's more than 15 years since the construction or the design of the telescope started. It will be nearly 20 years by the time it launches. So the timescales for solving all these big technical problems and getting to the point of launching the instrument are quite long. So if we don't think about the next generation telescope now and actually start, then it won't happen in our lifetimes. I'd like to think I'm going to still be around when it finally goes, but I may have retired at least by then.
So as the slide that Scott's showing is pointing out, this is going to be a UV optical wavelength telescope, and maybe also IR. Is that what I read somewhere as well?
Yes. Yeah.
So infrared as well. This worryingly distant bullet in your slide here is what you were just talking about. It takes about 15 years to get started, and if we start, then we'll, in the mid-20 or mid to late 2020s, we'll have something. Have we started? What's the status?
We've started a little bit. NASA,
that doesn't sound very promising.
Well, it's more promising than maybe I made it sound. You do need to solve a number of technological problems, and there are some specific things that you have to look at. You have to look at the optical coatings and do better with those. In something like Hubble, there are many, many reflections in all the instruments, and every time you reflect the light, you throw away a bit of the light. If you can make your coatings more efficient, so you throw away less, then you can gain a huge amount of sensitivity, and that means you don't have to make the mirror quite so big. The same thing goes with the detectors, the cameras. They have a limited efficiency. The best you can do in the ultraviolet, for example, is actually get about 30% of the light that hits the camera. The rest is lost because of the inefficiencies in the camera. If you can improve that by a factor of 2 or even more, you're gaining so much more sensitivity. And so a lot of work is already underway through NASA-funded programs for particular groups who are experts in these areas, working out how to solve these problems.
Go ahead.
Carry on.
Well, I just wanted to ask you about the coatings a minute. You were commenting on that. If we could get them more reflective and more efficient. In the wavelength range that we're talking about, is there one coating that will work? Like for JWST, it's coated in gold because of the reflectivity in the IR, but aren't UV and IR, are they equally reflective on the same surfaces?
Well, that's part of the problem. Finding a coating that's good across such a broad wavelength range is a real challenge.
Okay.
What works well in the infrared doesn't necessarily work so well in the UV. UV in a lot of ways is the most difficult area, because that's where the coatings degrade fastest in wavelength. As you go to shorter and shorter wavelengths, the coatings get less and less efficient. So there are some new techniques. There's a technique called atomic layer deposition, where you can really fine-tune your coating. You can make a coating out of a mixture of materials that work across a wide range of wavelengths. You can tune the thickness of the coating. You can overcoat it with a protective layer. So there are a lot of things you can do to actually solve that problem. The difficult bit is actually doing it on the large scale. There are trials that show that you can actually do the job and make very nice, efficient coatings, but then you've got to be able to put it on a 16-meter mirror. That's also a bit of a challenge.
Yeah, no kidding. Okay, so Tom Natha, I think it's Natha, I'm hoping I'm pronouncing it right. Kids, he comments, start learning origami engineering for the mechanics large-scale computer folding. That's right, career advice.
Absolutely. Yeah.
Very good career advice. Origami is definitely in a good growing field.
Yeah.
He also comments back on the Hubble issue, not so much a picture. This is again what HST means to him, but the data from the ultra deep field about the estimate of galaxies within the visible universe. That's what and that's a good comment. That was the point I was trying to make. Was it isn't so much the pictures as what they represent that have really affected me with Hubble.
I agree. I think that having frontier fields now too, allowing us to get more data in different places to see if that is the standard, or did we just get really, really lucky and looking at one point? So being able to do that again and again to get a better idea, get a better sample of what's going on out there, to see just how overflowing the universe is with these galaxies.
Overflowing. So here's a good comment from Tom Snyder. He says, perhaps Apple helped NASA with how to fold lightweight glass. Is that a bust on the new iPhone?
I think that's a Bendgate comment. Nice.
Nice. Kind of nasty. Oh boy.
Well, that's quite a tongue-in-cheek comment, obviously, but behind it there's a grain of truth, isn't there? Because there are lots of amazingly entrepreneurial and talented people out in these companies like Apple and, dare I say it, like Google, who are developing all kinds of things that have transformed our lives, just like Hubble has transformed our lives. And I think there may well be people who are not working in astronomy, not maybe space science engineers, who actually might have a lot to contribute in developing some of the approaches to these problems. I think we should really be broad about who gets involved in this kind of stuff.
Agreed.
It shouldn't just be us scientists. It should be everybody thinking about it.
Right. So getting back to ATLAST real quick, I wanted to. The technological issues you mentioned notwithstanding, let's assume for a minute we got it built. Where's it going to go? Is it going to go in orbit around the Earth? Are they going to put it at L2? What's the plan there?
Well, the plan will be L2.
Okay.
L2
That's crowded real estate.
Yeah, well, it's quite a big volume. Even a 16-meter telescope will get lost in there. But it is the place of choice for telescopes increasingly, because it's well away from the Earth, and so you get away from radiation called geocoronal radiation that's associated with the Earth's atmosphere, where light bounces off it and into your telescope. So, and also being away from the Earth, you don't get the Earth in the way when you're trying to observe something every half an hour or so. Hubble has this problem. It's in low Earth orbit, and so a lot of the time you can't look at anything because the Earth's in the way. So it's not as efficient as a telescope out at L2, where you can sit and stare for long, unbroken periods of time.
Yeah, but as always, the trade-off is, yeah, Earth orbits, you know, it's very bright, it's close to Earth, it's noisy, but you can fix things.
Yeah.
And yeah, going out to L2, a million or so miles away, is a little tougher to do. So this probably won't be serviceable either, much like JWST. So.
And I think that's been a really big, important thing about Hubble, is that we have been able to service it and being able to upgrade it, like we talked about earlier. And with James Webb, that means that we're seeing now, we have to do so much effort into making sure that it is perfect by the time it gets out to L2. Because if it doesn't go the way we need it to, we're kind of stuck with that. That requires a lot of testing on time.
Yeah, that's true to some extent. But why does it have to be the case that you can't service it? Because we're talking about will be launched in years' time, and if you look at what's going on in the human spaceflight program, we've got Orion coming on stream. Orion is a vehicle that's going to be designed to go beyond low Earth orbit, out into other parts of the solar system. Perhaps not immediately, but in the not too distant future, there are plans that an Orion-based system will be able to go maybe to the Moon, maybe to asteroids, eventually to Mars perhaps, in a few decades. But L2 might actually be quite a nice place to go for practice.
I think you bring up a good point, and I'm always so pessimistic, it seems, about the future of this stuff. Here's what you do, Martin. You design ATLAST to be serviced and make that a requirement, for people to go out and be able to fix it. And it'll just give one more reason for people to go back into space and to have our human spaceflight program reinvigorated. That'll be just one more reason.
I'll volunteer for the moon colony as well. And
I'll volunteer you too.
Yeah.
I think.
All right, sweet.
Yeah.
We'll have a Hubble Hangout from the moon, and then we can broadcast about the service missions going out there. I love it.
Yes. Okay, so Sev Dust Bunny is asking, would a new generation of Hubble need to be enclosed like Hubble or open like JWST? Martin?
I'm not sure I really know the answer to that at the moment. I don't see why it should be enclosed. Hubble is a design really going back to the late 60s, early 70s, and the ideas about how you built telescopes were
It looks like a
really
telescope
fixed and based on ground-based telescopes.
Yep.
Hence, it was an enclosed system. You do need to have some kind of enclosure for your instrument, but not necessarily in the way we did it for Hubble. Because you have to protect the instrument from the environment, make sure no nasty stuff gets in, keep it clean, and all the things that allow it to carry on working. But I think that kind of monolithic system that Hubble represents probably isn't something we'd repeat.
Yeah. Good question. Thanks, Sev. Cecil Morgan is asking, which Hubble, HST or Edwin, had the biggest impact? And I assume we're talking scientifically.
Ooh, that's a real.
I know. I was just thinking about that.
In a sense, it's an unfair question, because if Edwin Hubble had not done the work that he did, there would have never been a Hubble Space
Telescope. So that's right.
So I think you have to. Yeah, there's an order of precedence. It's the standing on the shoulders of giants question, to quote Isaac Newton, isn't it?
Yes, I guess so.
Everything builds on everything else, and if Hubble had not had that leap of insight into what was going on in the universe and transformed our perspective of the universe at a stroke, then I think astronomy would have not made the progress that it's made. Full stop.
Right. And when Hubble's research first came out, it had it hit like gangbusters when it came out. Even Einstein was really impressed by it. So it was pretty intense.
I think if we didn't have Hubble, we could have had the Zwicky telescope, and he just looks so happy all the time.
That's a great photo.
I'm sure it was happy sometimes.
Sometimes.
The Zwicky Space Telescope, yes.
Zwicky, yep.
Okay, Tom Natha again is going. Also, people treat the Hubble telescope more as a person. They really care about what happens to it and would like to bring it back down. You know, I'm glad that came up, because it is true. People really do. I mean, remember when we weren't going to repair it the last time, the outcry that came?
I do.
People got really upset about it, and now I have a feeling that as its orbit starts to get really seriously degraded, we're going to be hearing a lot of cries on that front too to go up and rescue it. What are your thoughts on that?
Well, I agree that the idea that Hubble would be left to rot after the Columbia accident really struck a chord with the whole world, didn't it? The reaction was just astonishing, and I shared the reaction. It was hard to imagine a world without the Hubble Space Telescope. Someday we'll have to face up to that, but I don't think we need to worry too much about the orbit. I think that's safe for a good while, is my recollection.
Well, that'll be the ultimate.
The issue for Hubble will really be how long the instruments keep on going, how long the pointing system can work. Those are the things that eventually kill you first.
Well, it'll kill it scientifically, but it'll still be there, and it'll still be savable. And so, you know, I think that's where the spirit of that comment was. It's just, you know, we want to, at some point after it's done, to go up and just grab the thing and, you know, put our hands on it.
Well, the difficult problem at the moment is you haven't got anything that can bring it back.
No. They did put a ring on there. I think John Grunsfeld did. Is that right, Carol?
Yes, that's true.
Yeah. Yes, there's a grappling fixture which allows what's called a controlled descent, so they can steer it as it re-enters. But because the main concern is the size of the mirror. It's a pretty darn big piece of glass you don't want to come down on somebody's head, so they want to steer it into the ocean.
But they still have to fly something to Hubble to dock with it. They have to be able to do that.
Very true. Very true. Okay, well, let's see. Let me look at the Twitter. Oh, I'm seeing Scott all over the place on the Hubble Hangout.
I'm never on Twitter, ever.
I know. Look at those great photos. Thanks for posting them. Is there any comments that you're running across, Scott, that I'm missing?
I see an interesting one on YouTube from Craig Landon, and I think it's an interesting idea, though I do see some issues there with it too, though. But I like the idea. ATLAST ought to be the first telescope that we 3D print at the ISS and send out to L2. I thought that's what the launch details. I'm like, well, because getting the shape of the mirror, I think, would be extremely difficult. But I could see actually doing some of the housing could, easily,
maybe.
Yeah, not so difficultly be done. At least some of the scaffold to put it together. But we have been talking about doing 3D printing in space, and there's a lot of new and interesting things. But we also have to get the stuff out there too, which means we have to launch it in the first place. So that same amount of fuel is going to have to be used to get the material out there. So I think personally, economics-wise, you might as well build it down here and make sure it's exactly the way you want it to, since you're going to be using the same fuel amount to get that matter out to space.
Yeah, I think.
What do you guys think?
I agree with you. And the other thing is that it's like you want to test every single part of it, and it's working together. And the station is a difficult environment where you're going to assemble something, and then you're going to try to test the whole thing there, and then try to fix what didn't work. So logistically, it would be easier to do testing on the ground.
There's another problem with the space station, is that it's a dirty environment.
Yeah, well, there's
and a telescope like this, you want to keep that mirror really, really clean.
Yeah.
So you don't want to take it anywhere near the space station.
And it smells like filthy humans too, so we don't want that.
Yeah.
It sort of pushes in a slightly different direction, because one of the things that really got me hooked, apart from wanting more UV astronomy, which is my particular interest, one of the things that really got me hooked about ATLAST, and why I'm pushing it in Europe and trying to get European interest involved in the way we have European involvement in Hubble and in James Webb, is what it's going to be able to do for astronomy. And although it will be a great observatory in the way that Hubble is, it can observe lots of different things. I think there are one or two really, really fundamental pieces of science that it can do that nothing else will be able to do. And for me, it's this ability to go out there and image Earth-like planets around other stars and then take a spectrum of those planets to see what the atmosphere looks like and whether there's any evidence for life. That, I think, is going to be just a completely revolutionary piece of science. Obviously, you've got to find the planets to look at first, and there are many missions already doing that. But because of the size of the mirror, you'll be able to zoom right in around nearby stars into the habitable zones and look for rocky objects around them. And that's got to be one of the holy grails of astronomy.
And that's it's a good point. For those of you who don't know much about telescopes, the diameter of the mirror is directly related to what you can, how small you can resolve objects. And since these planets are so far away and they're so difficult to see from their stars, next to their stars, a high-resolution telescope is almost it's crucial to be able to observe them directly. There is a question from Etha. Maybe you could answer this one, Carol. Speaking of the pointing system, how well is that working? The pointing system on Hubble.
The Hubble system is working great. We do have a gyro that failed, but we have 6 of them, and we can operate probably all the way down to 2. So the pointing system is exquisite.
And some of them are being saved, right? They're not all in use.
Yeah, that's right. And they're monitored all the time. There are engineers who look at every little glitch to estimate whether every single system is examined all the time to make sure if there's any indication that something is going wrong and to see if there's a way to get around it. And then also there is a guide. We have guide stars. So the guide star is acquired in the guide star system then locks the telescope on a star so that the main field that's being observed will be rock solid in the instrument. And it's so good that we can also track things like not only stars, which move as the Earth turns at a certain rate, but we can also track objects in the solar system like comets and things like that, and planets. So it's a really good system.
Good, thank you. Thanks, Tom. That was a good question. And he's also asking, or he's commenting, that with 3D printing, you still need to get the mass up there in order to build whatever. So.
Wait, yeah. Does that mean I was right? Wow.
Wow, how did that happen?
Birthday, one day a year. I get
birthday smart.
Awesome.
Birthday right.
Sweet. Thank you, YouTube.
All right. Well, so Martin, I know this is that the ATLAST mission is in its nascent stage here, and it sounds like things are a little bit fragile. What are your feelings on how this was going to go? Are you confident that this thing's going to get built, or?
I would say hopeful is the current stage of things, because there are a lot of hurdles to overcome before you even get to the stage of having what you might call an adopted, approved mission. It's a big, expensive thing, and therefore it's going to require a large fraction of NASA's budget if it was to build it, as well as the European Space Agency and whoever else joins in. This probably has to be an international.
Yeah, I'm glad you brought. Yeah, good. I wanted to get your thoughts on that. If you thought they were.
But I don't doubt that NASA probably will be the leading agency because of its experience with Hubble and James Webb. So there's a long process to go through to get the agencies behind it, get it. I mean, in the US context, it has to be picked up in the next astronomy decadal survey. These 10-yearly things where.
Explain what that is real quick. That's a real important thing, the decadal survey. Why don't you explain what that is?
Are you going to do that?
I can. So in the U.S., not surprisingly, every 10 years, that's why it's called a decadal survey.
Decadal survey.
The astronomical community gets together and appoints a committee to represent them. And then the idea is to look at what the scientific priorities are. But there's also this pressure from the agency, both ground-based and space-based, so it affects the National Science Foundation as well as NASA. And what are the burning science questions? What are we going to know, in the year 2020, and then how are we going to spend our money? So it takes a year or two to actually get that survey together and get the report together, because a lot of people, the community is supposed to have input. And so you want to try to match the budget with, we're supposed to look at the science only, but you can't do that in a vacuum.
Right.
And so you have to have some notion of what the budget might be. And other disciplines are doing that as well. So the idea is to have the community do the priorities on a scientific basis and then try to match that with what kind of funding would be available.
Do you think there would be any problems with that getting in the survey? Is there a lot of support for this mission among astronomers?
I think there's growing support. I think it's important for that support to build up.
Yes.
Because the survey isn't going to choose a mission that hasn't got pretty much overwhelming support. Something this size, everybody's got to be behind it, really.
Yes, because just for context, JWST was the top priority in one of them, and I think the last decadal survey it was W first, correct? Yeah. And that's also being built right now. Yeah. So ATLAST would need to have that same level of support.
Yeah, and it needs to be recognized as the next thing to do in the next decadal survey. Mm-hmm. I think there is a positive note that the last survey recommended that the technologies for doing this should be studied. So there is a natural next step that, having done that for 10 years, when we come round to the next report, that hopefully the technologies will then be ready. And that's really partly learning a little bit from some of the problems experienced with James Webb Space Telescope, where some of the technologies were still a bit immature at the time the telescope was selected, and therefore more problems were encountered in implementing the telescope during its development phase than you really would like. So it's a little bit about anticipating some of those difficulties and solving those problems now, so that when we do finally get an approval to go ahead with something like this, we're in a better position to do it.
That's right. Go forth and invent things so that we can have this telescope. Go out there and be inventing. Okay, well, Dr. Martin Barstow, thank you so much for joining us on this. And let me ask you, will you come back? Will you give us an update on ATLAST at some point?
Yes, definitely.
We haven't scared you away. Scott
we may have to wait a few years before there's something new to say.
But
I'll happily come back again.
It'll go by quickly.
We'll come back next year, and maybe I can say another correct thing.
Yeah, on his birthday.
It'll take at least
a year.
It'll take at least that long for you to be able to.
At least.
Yeah. Okay.
Yeah. Thank you very much, Martin. We realize it's evening time for you.
That's right. And go get that glass of wine.
Thank you very much for participating.
Yeah. Thank you very much. All right, guys. Well, that's it. That's it for this Hangout. I want to thank you guys for watching. Next week, we will be talking again about 3D printing with our Made in Space guys. So hope you guys will join us for that Hangout. Thank you guys. Carol, Scott, another good one. Thanks for all the help and all the stuff. Thank you guys for
that's what I'm here for.
All the stuff, yeah.
Sometimes
all the stuff and then some. Yes. Yeah. All that good stuff. Thanks, guys. Thanks for watching, everybody. And as always, keep
it up.
That's right. Bye-bye. Bye. You could give us a comment. Give us a brief introduction on what your thoughts are on the kinds of science, both the science impact and the effect it's had on the general public.
Yeah, well, Hubble is the most well-known telescope on the entire planet, isn't it? Although obviously it's not on the planet; it's out there in space, orbiting the Earth. And that is really the key to why it's been so important. Getting up outside the atmosphere gives you a view that none of us can have from the surface of the Earth. It gives you access to images that are not obscured by the atmosphere. It gives you access to different wavelengths of light that the atmosphere normally blocks, like ultraviolet and infrared. So the impact has been colossal because of that particular vantage point. One of the interesting things I find is that actually what you also get is a very dark sky. We get outside on a moonless night, and the sky looks dark to us, but actually there's a lot of light out there that telescopes don't like. If you go outside the atmosphere, you get rid of all that, and you get rid of the background, and you can see much deeper than you can from the ground.
Let me tell you how you can interact with us. We hope that you will leave us comments and questions and tweet at us and all kinds of things, and we'll read them out throughout the Hangout. We got so many last week I didn't get to all of them, so I'm going to start earlier this time, and we're going to go throughout the Hangout with your questions and comments. So you can do it by using the Q&A app. That's the easiest way to do it, which is right there if you're on YouTube and Google+. You can also leave comments on YouTube and G+, and also on Twitter, use the hashtag Hubble Hangout, and we'll see those as well. Last week we had some pretty good interactions with those, and I'm happy that you guys are doing Twitter more on that as well. So thank you, and start commenting and leave your questions. So as I said before, we have Dr. Martin Barstow with us. He is the professor at the University of Leicester. He's also the president of the Royal Astronomical Society. And Dr. Barstow, thank you for joining us.
That's my pleasure.
Okay. For 24 years now, the Hubble Space Telescope has been circling over our heads and providing us and astronomers with views of the universe that have helped us not only understand how the universe works, but and our place in it, but has given us, I think, a lot of insights that I would bet most people didn't even expect to have before Hubble was launched. And I've often said that I've often called the Hubble Space Telescope the most important scientific instrument ever built because it has had such an effect, not just on the science and our understanding of the universe, but also the effect it's had on our culture. And I think anybody that knows anything about the Hubble Space Telescope and has seen some of the images that come out of it have had some kind of emotional reaction to it. I mean, I've told people often the story I had when I first saw the initial Hubble Deep Field in the 90s, in the mid-90s, and it wasn't until I understood the context of how that image was taken that it really hit me hard emotionally, and it in no small part led me straight to the job I have now. So it's affected my life in a lot of very personal ways, and I thought I think when Hubble was first being planned and launched, do you think that astronomers really had a good understanding of just how big a difference it was going to make, or was it always kind of understood?
I don't think so. Whenever you build a telescope like that, and I've worked on a few space missions, including Hubble, over my career, you have some ideas about what you expect to do. Otherwise, nobody gives you the money to build them. So you have to say what the science is going to be. But everybody always hopes underneath that there'll be things that are a great surprise. One of the things that have made Hubble such a great surprise is the ability to keep changing the instruments, to repair instruments, to put on better instruments. And all the time, Hubble has become more and more sensitive and more capable as those things have changed. So unlike most telescopes that tend to stay the same over a few years, and you start to run out of ideas of how to use them after a while, Hubble has kept on going, and the ideas have kept flowing through, because every time we have a new instrument, we have a
Hello everybody, and welcome to today's Hubble Hangout. My name is Tony Darnell. I work at the Space Telescope Science Institute, and today we've got a really interesting hangout planned for you. We've got Dr. Martin Barstow, professor at the University of Leicester, and also the president of the Royal Astronomical Society with us today. He's going to be providing us with a great introduction into not only the scientific and cultural impact of the Hubble Space Telescope, but also we're going to talk a little bit about the ATLAST mission a little bit later on in the hangout. But before I get started, let me introduce my cohorts. One of them is a birthday boy today.
Oh gosh, Carol, it's your birthday.
No.
Scott Lewis, our internet rock star, turns 16 today. So
yeah, 16.
Yeah,
yep,
that's great.
Absolutely.
Welcome. So congratulations, Scott.
Thank
Also
you.
Also back from her hiatus from the workshop last week is Dr. Carol Christian, the Hubble Space Telescope outreach astronomer. Hello, Carol.
Hello.
Okay, before we get started with today's hangout and the introduction, let me